Yes, Subhash.
Good morning and a warm welcome to one and all present here for the webinar organized by Department of Electronics and Communication Engineering. I'm Subhash R, student of St. Joseph's Institute of Technology. I'm here to volunteer for today's session. Now, I request Dr. Gnana Kausalya ma'am, Professor and Head of Staff and Student Affairs, to take over and address the session.
Thank you, Subhash. Good morning, Mr. Sumant and all the participants. This is Dr. Jnana Kausalya, Professor and Head, Department of Electronics and Communication Engineering, St. Joseph's Institute of Technology, St. Joseph's Group of Institution, India. It's my distinct honor and high privilege to welcome our guest speaker, Mr. Sumant Rajagopal, software engineer, IBM Corporation, California, USA, to give a talk on here it is with the cloud security, common vulnerabilities and ways to address them. Thank you, Mr. Sumant, for accepting our invitation, and we are very much honored with your presence. Welcome, Mr. Sumant Rajagopal. Our deep felt respect and gratitude to our beloved chairman, Dr. B. Babu Manoharan sir, Managing Director, Madam Mrs. Jessipriya ma'am, and Director Sir, Mr. Sashi Shekhar for their kind support, and also to our principal, Dr. P. Ravichandran. Dear participants from the various organizations, welcome you all, and I hope that you enjoy the maximum learning in this webinar and also to be an interactive session. Now to introduce about Mr. Sumant Rajagopal, he is a software engineer at IBM Corporation, California, and he has worked in software development roles in relational database products, including the server technologies and administration products with web technologies. He is currently working in secure engineering roles, including the security and compliance of data and AI products. And he completed his degree, the UG degree. He holds a BEC from GCT Coimbatore and MS in Computer and Information Sciences and Engineering from University of Florida, USA. Nice to hear. That is Mr. Sumant. Your presence here, it is a valuable one for us here. And welcome again, and thank you all for the participants for taking the efforts to participate in this webinar. And thank you all once again. Now the session is over to Mr. Sumant Rajagopal, our guest speaker. Thank you.
Thank you, Dr. Jnana Kausalya. Thank you for the warm welcome.
Thank you.
Good morning, everyone. I hope I guess it's almost lunchtime there for you. It's really an honor to be spending, to have the opportunity to talk to you all today. I hope to spend the next 30 to 60 minutes talking about this. These are I hope each one of you and your loved ones are doing well and doing fine in these trying COVID-19 times. This is certainly an unprecedented and unique time in history. I'm sure all of us will come out of this wiser and stronger from this challenge. Best wishes to all of you and your families, and hope you all stay safe. Again, I'd like to thank Dr. Jnana Kausalya, HOD of ECE Department at St. Joseph Institute, to invite me for this talk. Thank you also to Assistant Professor Emmanuel for working on the scheduling and the logistics of this event. Thank you both. I'm really, really excited to be presenting this topic to you today. I know there are a lot of students in the audience, a lot of faculty members as well, and people from the field, professionals who are working. I actually gave a very similar presentation to IBM engineers, and it was very well received. So when Dr. Kausalya approached and said, can you present on any technical topic, or it can also be, say, career placement tips or motivation talk for the students, this is the topic that first came to mind. And then I also thought, why not combine this with also some life lessons learned kind of a thing. So I kind of combined both. So the first part of the talk, we'll talk about cybersecurity and common vulnerabilities. And in the second part, I'll share my life lessons learned. And at the end, I hope we'll have some time for a question and some question answers and discussion and so forth. So I hope you all enjoy and gain some insights out of this session. So let me, yeah, I'm sure you can see my screen right now. So as Dr. Kausalya introduced, I'm a software engineer. I work for IBM. Although today I'm presenting in a voluntary capacity and not representing IBM today. Um, like she said, I've been working on software technologies as a software development engineer, both on server technologies and the admin tool. We used to encounter a lot of security issues while developing code. So at that time, I was purely a developer, would face security issues and fix them. Then the last 4 years, I've been primarily focused on two things: secure engineering tasks and compliance. With secure engineering tasks, I mean things like static code analysis, a dynamic web application scans, and so forth. And the compliance is products that are being sold to companies. There are a lot of regulatory bodies. I'm sure there are in India as well, and in the US, things like ISO, SOC 2, HIPAA. Don't worry if you don't understand those acronyms, but I'm sure you're all aware that there are regulatory bodies and regulatory frameworks, and a lot of companies, before they adopt products, they would make sure that those products comply to those regulatory frameworks, and that's what we do in compliance. So with that introduction, I hope you can see my slides. So this is the agenda. We will talk about a brief introduction and overview of security. I'll show you a common cloud service system architecture and use that as a basis for the security vulnerabilities that we'll talk about today. Then we'll talk about OWASP Top 10. OWASP is Open Web Application Security Project, and they come up with the top 10 vulnerabilities. So we'll talk about that and take a few examples and delve a little bit more deeper into those. So that's the common vulnerabilities using examples. We'll take some of those OWASP top 10 and look at it using some examples. Then in this first part, I'll conclude with a notable industry exploit. So there were some very popular in the news, I should say, very huge security breaches in some of the biggest companies. So I will briefly talk to you about those exploits. And like I said, the second part, I'll share some of the life lessons learned and share my insights with you, and hope it is useful for you as well. So what is security? So in the United States, the Department of Homeland Security, which is tasked with protecting the people of the United States within the United States, defines it like this, right? So cyberspace is so important that every citizen's daily life and economic vitality depend on it. Pretty much anything that you take, transportation, power, banking, media, telecommunications, all of these run on computers, software, internet, and all of that. So you can see how critical cyberspace is, and protecting them, how critical that is. There are very sophisticated hackers who are trying to break these systems, right from very individual, the proverbial teenage in his basement, a single person trying to hack things, to nation states. There are big nation states who have armies of people who try to break into other, just like a military or physical warfare. There are people trying to break into other countries' cyber defenses. So you see how important and how humongous the task is for securing the software systems. So this is an example I took from the United States Department of Homeland Security, but similarly in India too, there is the National Cybersecurity Policy. The Ministry of Electronics and Information Technology has a national cybersecurity policy. Um, I'm sure the intent of this is very similar to the US system. It is out there on the website that you can take a look at, the National Cybersecurity Policy. So let's see what the definition of security is, right? A definition. There could be many definitions, but one such definition is at the base, it is protecting the expected functioning of a system from unintended consequences. Just think about it. There is a system that's functioning and you need to protect it from any unintended consequence. It could be a malicious hacker or even unintended ways in which the functioning of a system can be interrupted. So that's what this security definition. And in a system is only as strong as its weakest link. So it's important to have strong defenses in the system, because anybody who can exploit the weakest link will get access to the system, right? So it's important for the system to be as strong as possible. So there are large companies spend huge budgets and have entire departments devoted to security. I mean, we saw the need for security, and customers who buy from these large companies are also big companies in medicine, telecommunication, media, and all of those big companies. They're all hugely, they serve millions of customers. And so it's very, very important to secure those systems. The clients value security to the utmost. And proportionately, the companies that build software also put in a lot of effort to build very, very secure systems. As a layperson, some examples of security could be, you could think of a credit card being hacked, or the credit card being exposed, your personal credit card being stolen, right? But banks these days provide liability-free. So if somebody were to break into your or steal your credit card and charge it, banks would have a zero liability for you. So as a consumer, maybe you don't feel that particular thing is very harsh on you. But if you look at the other side, the bank, somebody has to bear that cost. And so if you look at banks and financial institutions, they have huge line items in their financial statements, which provide for these losses. So somewhere there is a monetary loss, and it is in the best interest of the software providers who provide the software and the companies to prevent those. And so every step of the way you see security as being very critical. So the security mind. So in today's talk, I mean, if there is one thing, one of the main goals is for somebody who's not initiated to security, hopefully they can go away with an appreciation for the security, the common vulnerabilities that are present, and an awareness of security. And they can go dig deeper and find out about as many vulnerabilities as possible and get themselves educated. And for somebody who's already familiar with security, I hope this will provide a refresher and provide some new insights that maybe you haven't encountered before. So I hope there'll be something for everyone here. And the other thing also, I hope you can take away from this talk is the security mindset. What is the security mindset, right? So you always put yourself in the shoe of a software developer. When you're writing software, are you taking care of every condition that's that you're coding for? What can go wrong? Be a devil's advocate for your own code, right? So when you're writing code, think about all possibilities. So that's part of the security mindset. So it's not only software developers, so anybody who's configuring systems, or even anybody who's using systems, asking questions about what can go wrong. So have the security mindset. That'll help a long way in securing systems. Right? So if we see broadly, we can classify security into these three main categories. One is information loss, which is privacy, etc. We just talked about one example of the credit card information being stolen. So like that, there are so many other examples, and it also depends on various cultures and geography as well. So for example, in the United States, things like social security number, it's like the Aadhaar number in India, right? The social security number, date of birth, driver's license, all those are considered personally identifiable information. And for businesses, their financial statements, trade secrets, intellectual property, all that is protectable information that has high value to those stakeholders, and so they want to protect it. And the intention is not to lose any of their information so that it falls in wrong hands. Then access control. What do we mean by access control? So there is a system functioning and it's intended to be administered by certain people, but due to various reasons, intentionally or unintentionally, we don't want access to be taken away by anybody who's not intended to access that system. So that is also a form of a security parameter. And a third is availability of the system. The intention of any software system that's running is for it to be available whenever it's intended to be by all its users. So that is of paramount importance. So we make sure that the system is always usable, and anytime the system comes down, it could be due to intentionally or unintentionally somebody breaking into the system and causing it not to be available. So that is also a security breach. So these are, if you can demarcate security into these three categories, and we'll see all of these. So this is, I know this chart is full. The intention of this is a typical order management use case. It has several different components in it, so you don't have to worry about each of those. The point is to show that a typical software system can have so many interacting parts in it. So if you take all the way from the left, how the users interact with the software, either through your mobile phone, your tablets, a desktop, computer, browser, or any automated programs. So all of this will interact. And as you go towards the right, you go through the authentication, the edge layers, where there is firewalls, software firewalls, hardware firewalls, edge processing, and then going through authentication, and then you get into the business logic of the order handling in this case. And then as you go towards the back end, the data is stored in different databases, storage systems, search systems, analytic systems, and all of those. So you can see how and you can see the data flow between all of these different components. And it's very important to secure all these individual pieces. In several cases, in spite of redundancy being built into these, there could be cases where even the malfunctioning of one system could affect the whole, the entire system. So what is OWASP Top 10, right? Like I said, OWASP is Open Web Application Software Project. It's a nonprofit endeavor, and it's funded and sponsored by technology companies. So basically, technologies evolve over the years. Several decades ago in software, so Unix and C might have been really big. Of course, they are still very, very big in a lot of systems. But over the years, there are newer technologies that have come up. PHP, Perl, and later on Java, JavaScript, Python, R. There's so many languages, so many technologies, Linux, Windows, all those operating systems, several technologies have come. So as these come, each one brings with it its own strengths and weaknesses. So based on the trending security issues, what researchers commonly find, the OWASP project publishes the top 10. And these are the top 10. It's all out on the web, so I'm not going to read through each of these, but we'll take a few of these as an example and delve deeper into that and see how these common vulnerabilities work and how are some of the ways to mitigate them as well. So the first is injection. So injection can be many things, right? It can be a SQL. SQL is, for those of you who are not familiar with relational databases, SQL is a query language used to query data from relational databases. So injection can be SQL, script injection, and so forth. But today we'll talk about SQL injection. Again, when we talk about SQL, basically a relational database management system, data is stored logically in the form of tables. So this is an example of a very basic table, right? So it has one column with users and one column with account balance, right? So that's a table. And just imagine any application that can access this table. So you want to access the username and the account balance for some, say, banking application. So you enter a name, and then it returns back the bank balance of that person. So for example, you'd write a query like this, what's in white there. So don't worry if you don't really understand SQL, but all you have to know is there is some code that's executing to go and get this data from the backend database. And this is the structured query language SQL code that does it. So we say select username and account balance from the table where username equal to, and then we get a parameter. So I've used Java here as a pseudocode to kind of explain the things, but it can be any language. The databases and the languages are all pretty standard. They all have the same capabilities to affect these operations. So what's in white is the actual SQL, and where the request parameter is where whatever, say, imagine yourself entering the name in a text box. So say, for example, in this case, you input Bob. So that Bob gets appended to the SQL, and then in the back end, it goes and queries the database to get the username and account balance for Bob. So, okay, good. So it returns Bob with whatever the balance was, 50,000, 5,000, whatever it is. It returns that back. All that is good. That's the normal functioning of the system. But now imagine somebody who's knowledgeable about the backend system, say they know that a SQL, for a normal layperson, they would not know what technologies are being used. But somebody who's very knowledgeable, they would know if a SQL query is run, they can say in that input box, in addition to Bob, they can also add a SQL state predicate to it. So in this case here, you see they could do enter Bob or 1 equal to 1 in that text box. So what that translates to is, as you can see, where username equal to Bob or 1 equal to 1. 1 equal to 1 translates to true. So how relational databases work is they go and check each row to see if the condition matches. Is the username Bob, but you have an OR condition here, a predicate that evaluates to true. So essentially every row will match. So the output of this will be the entire table. So you saw Bob, Caroline, I don't know, Money, Selvi, whatever it is. So all of this will be output. So now anybody, say Bob will now be able to see the balances of every other person. So you see how this is one of the very basic cases of SQL injection. How just entering a different input will will help you to expose, break into the system and have access to information that you're not supposed to have access to. So that is a problem, right? So how do we mitigate that? So in SQL, there is the concept of prepared statements with parameterized queries. So what that does is it prepares the SQL statement ahead of time. So again, what's in white here and what's in the question mark is that part accepts only data values. So that's how prepared statements work. So now when you enter Bob, you will get Bob's, or if you try to enter Bob or 1 equal to 1, so essentially it'll take Bob or 1 equal to 1 as a string and it'll look for that name in the table. And now it's not going to match. So it's going to come back with an error. So that can only be a data value and it cannot have a predicate of the SQL. So that's what prepared statements and parameterized queries would do. It can only have a data value. So instead of writing a query, a normal query, if the best practice is to write a prepared statement. So that way you prevent this simple SQL injection from happening that would break into a system. So this is one way to prevent SQL injection issues from happening. So the next one of the other more common ones is cross-site scripting. So here again, in an input box, you enter the name, in this case, whatever name, product line prediction, machine learning model, and you append this other script like snippet there, on mouse over equal to alert document. So again, this is a script snippet. So this one, if it's entered, and if it's not being sanitized, this becomes the name of that particular project, say in this case. And what happens here is, actually I had a small video like, okay, let's see if that plays. Let's see if I can get off of this. Okay, there you go. Okay. So there you see, that's the name, and if you hover over it, it actually exposes the cookie, of the from that document of the person. So right here, you've seen a script that's been injected into the name and it's being exposed. So this may be harmless by itself, but say that a particular document is being fed to a malicious other website, a cross-site scripting being fed to another website. So somebody third party can access your cookies, and that becomes a security violation, right? So again, here, in all of these, you see how important it is for input sanitization. So you should check for all of the inputs. So script tags and some sorts of function calls are not allowed in names of projects and stuff like that. So it's very important to do input sanitization. If it's not done, then we could run into issues like this. The next one I wanted to talk about is sensitive data exposure. So in the web world, it's very REST APIs, and HTTP is very, very, very common protocol, right? That happens. Request and response happen all the time between all of those different components. If you can imagine the order management system, I said there are all these microservices that make up that system, and all of the data that's being transferred between all of those modules is request and response messages. So we have to make sure that there is no sensitive information that's being passed. Username, password in this example that you see is one such example. There is a lot of encryption and being required these days, and it's very standard, but still such username and password and sensitive information should be very carefully passed, because sometimes this information can be logged in plain text and so forth. So that it's very important to manage sensitive information like passwords. So one way to mitigate that is you have access tokens that can be generated, whose duration is very short-lived, 15 minutes, 20 minutes, half an hour, and so forth. So the validity of that access token will be for a very short duration. So the risk is vastly mitigated. So this is another such example. In a response message, say something doesn't work well, and the response, the error message could have a username and password, which says that's a problem, right? So again, we have to be aware of it. In some cases, you might have to do it, but you'll have to mitigate the risk, be aware of what's being passed, and mitigate any of those kinds of sensitive information that's being passed back and forth, so it's not being pried upon by malicious actors. So one last example in sensitive data exposure. Again, here, it looks like all gibberish, but that part in white on top is an intended malicious payload to try to break the system. So when that happens, the response becomes an error response. And in the error response, you see the source code details being passed at the bottom. It has the file, the line number, and the column, and so forth. Though there is several open source software, we don't want to expose where we have a problem or what kind of software the system uses. The more information you provide, malicious actors can piece together information to cause harm. So as much as possible, we try to prevent information such as stack traces and source code information from being exposed. For some debugging purposes, it might be necessary, but there are ways to mask that with some authentication, special authentication only for tech support and that sort of thing, right? So those are ways in which to minimize sensitive data exposure. A security misconfiguration. So again, there could be several things. This is one such example. For example, so when HTTP messages are being passed back and forth, HTML and HTTP headers can provide how things are being configured. So frames, as some of you might know, is like, you can think of it like a picture-in-picture PIP kind of technology, right? Where in a TV you have two screens that you can view. On a web browser, you probably see it all the time, but you don't realize different parts of a web browser can have data coming in from different sites. So this is one of the options where you can ensure what kind of sites you allow. So for example, you are mindful of third-party sites that you want to allow, or sometimes you don't want to allow any third-party sites to feed data into your website or web page. So these are options to be mindful of while configuring it. So this is an example of such a site. So you might have all seen examples like this. So this is a zip example where the user wants to go and zip up some files from their file system, but that start now there is so bold that you're tempted to click on that. So you might think clicking on that will start your zip operation, but in effect, that is actually an ad here that takes you to a third-party site. This may not be malicious, but it's definitely not what you intended to do, and it's definitely intended to mislead you. So this is an example of a frame within a web page that could mislead you into doing something that you don't intend to do. So I'll bring this slide up again to re-emphasize how various microservices have data flowing between them, and how a large complex system is composed of, and how any part in one of it, failure in just one part of it, could cause unintended consequences. So again, in the security misconfiguration here, so how many of you have seen things like this where it keeps spinning and spinning? So like I said earlier, each of those modules can be fed from a different a microservice in that architecture that you just saw. So any one of these components, because of security misconfiguration, say, or any other issue, is not able to return data back, and so the user, it keeps spinning and spinning. So you can clearly see in some e-commerce sites, for example, there are several statistics which say if you don't return the data back within a few milliseconds, then the user tends to go away to another site. So that right there is loss of dollars, right? So you have to be very careful about how these things work and make sure that the user has the intended experience, and such things due to security or whatever reason don't happen, and the data comes in a very timely fashion. So the last thing in the security misconfiguration is the 500 internal server error. So that's an error which is an unexpected fatal error that happens on the server side, which is not supposed to happen. So anything that happens should be considered a critical or an emergency and be fixed. Again, in the example where you saw before, where the website kept on spinning, so the client, just like the server, the client has a protocol to handle such an error, right? So when they say, for example, get a 500 internal server error, they could say, okay, there is probably a temporary failure. Let me time out and go and try to ping the server again. Maybe it's come back again. So that's why it's very, very important to fix internal server errors as soon as possible, because there could be clients that are timing out, waiting for a response when they see a response such as a 500 internal server error. Per the protocol, it's important to fix such errors as early as possible. So this is another one such message that can come out of that. Okay, components with known vulnerabilities, right? So I just talked briefly about open source. I kind of alluded to open source components before. So nowadays it's very, very common for big software systems to be made of large part with open source software. Open source is you and I, anybody can go and look at the source code. So large companies work with open source. They combine different open source and then solve a client's problem. That's where the value proposition of several large software products is. They're able to put together multiple open source products and build, say, an analytics product or whatever it is. So this open source is available to everybody. And they're finding security vulnerabilities in this and patching it. So it's not enough that you find the open source and incorporate it into the product, but also keep abreast of any updates that are happening to those open sources, because they're sending out patches. So constantly keeping it patched so your entire system stays secure. So there are several tools. I've mentioned a few at the bottom. There are several tools available to help you do those checking of those third-party libraries and open source packages and so forth. Okay, so the last part in this, the security part, is I mentioned a couple of vulnerabilities that were quite popular or quite well known in the news. So this was back in September 2018. Facebook had a huge breach affecting about 50 million users. It was being talked about at that time constantly for weeks on end. Everybody was talking about it because Facebook, as you know, has more than 1 billion users. So everybody is talking about it. So I was quite curious what could have been the security breach, and I was reading through tech articles and so forth to kind of understand. And this is what I found, what led to that. So it was not one particular bug that caused this. It was 3 different bugs when combined caused this breach. Facebook used to have a view as feature. I believe it doesn't have this anymore. But anyway, it was not the view as feature itself. But when you use that feature, there is a video uploader capability. First of all, the view as feature was not supposed to have the video uploader. So that was the first bug. The second was the video uploader generated the access token for a mobile app. Again, that was not intended. There was a bug that caused that. And the third was view as. So the view as feature is, so you have your Facebook profile, you put in data into Facebook, and then you can control who sees what. Public can see this, your friend or certain group can see this. So you put in some data, and then you want to go and see view as public or view as your friend, how that person sees what data you have. And then when you say view as, say, for example, your friend, Bob, here in this case, Bob's access token is accessible to you. So you see the problem there, right? Once you have Bob's access token, you essentially have access to his Facebook account. You can be Bob in Facebook then. So that's why it was so huge and it was in the news. So again, it comes back to your system is only as strong as the weakest link, and no bug is small enough. Maybe the bug by itself may not be a big thing, but put together they could cause a bigger problem. So this is one such example. And the last example I wanted to show here is the Equifax breach. Again, this was huge. Equifax is a credit reporting company in the US. So what do they do? So say you go and apply for a loan, car loan or a mortgage or whatever it is, the company that provides you the loan will reach out to, there are 3 companies, Equifax, TransUnion, and Experian. So these are the 3 main companies that provide this data to the loan providers, the banks, whoever it is, who verify your credit history. They have what is called your credit history. So they have your name, social security number, your credit history. You build credit history. As you pay your credit card bills, as you pay any other loans you have, you build up credit history. So they have your history for a long time, right? So again, you can see how important this data is. So you have name, social security number, date of birth, driver's license, all of it. So when it was compromised, any hacker who gets this information, they sell this information on the dark web. What does that mean to the person? So when somebody has this information, and so basically they can apply for a loan as you. So they get money on your name and you become liable for that loan. So again, you can see how big of a deal it is. And 143 million users have been affected by this breach. So what exactly happened here, right? So Apache Struts is an open source package, and that was a framework used on their backend systems, websites, and so forth. And so there was a vulnerability found, and it was fixed and announced on the same day, which is March 7th of 2017. They said, hey, this Apache Strut, this version has this vulnerability, and here's the fix for it. And the exploited Equifax happened 2 months later in mid-May of 2017. So what that means is, it again goes back to my point a few slides ago about updating your patches often. So 2 months, they hadn't updated the patch, and somebody who's looking for a vulnerability found it and exploited it. 143 million users. I say September 2017 there because it took several months even for Equifax to realize they had a problem, and then they had to mitigate it. And by the time it came out, it was September. So you can see how huge and how many people, there are billions of dollars at stake here. So very important to keep patching your open source systems. All right. So I think, yeah, that's what I wanted to cover in the security part of it. I know I probably went a little bit fast in some of those, but I meant to take a few of those OWASP top 10 and show you a flavor of what the vulnerabilities could be and how to mitigate them, and how important it is to patch the systems, and how very popular systems and how impactful the security breaches have been using these two examples that we saw at the end. So like I said, so that's the security part of it. Now switching gears, some of the life lessons learned. So over the last several years, a couple decades, what are the things that I have found that are very important? So these are my personal insights. I hope you find it useful and find a value out of it. So I've listed 4 here. One is learning to learn, right? That is very important. Learning is something that's lifelong. You sit in your, as students, let me take the example for the student audience here. So you have your course subjects that you study. For some of you, you might take the book, go and sit in your desk, study, and that's how you learn. For some of you, you talk to your friends, do group study, and then that's how you learn. Some of you might go to your professors, talk to them, faculty, and get their insights, you learn. And for most of you, it's probably a combination of all of those. So while it's important to learn the subject, it is very important to also understand how you learn, because learning is a lifelong process. Anything that you learn right now could become outdated in a few years, right? So for example, when we were in college, our professor said his thesis was on vacuum tubes. Vacuum tubes, I mean, as you know, is not being used these days. And when we were in college, we used to focus on things like 8085 processors and 8086. And you know how things have evolved, and there are several generations of processors and so forth. So the point is, what you learn, the knowledge is good, but things evolve and you have to keep learning. So learn to learn, that is very important. The second is communication skills, right? That is very important. Again, what you learn is very important with your professors, for your subjects, for your exams, and so forth. You learn the content, and that's how you become useful to a company when you get a job and stuff like that. So you end up getting a job or doing something, right? You do something. That is one part of it. You solve a problem, that's one part of it. You fix a bug, that's one part of it. But the second part is you communicate that to your stakeholders. How you designed it, why you fixed it, how they can use it, what are the interactions they can do with the product you did. So all that is communication, written communication, oral communication, and so forth. I'll just take one example in my case. When I was, right as I was finishing grad school, master's, and I was applying for a job, like I said before, I had done in databases, right? Relational database management systems. So I was interviewing it with some of the biggest database companies at that time, right? Uh, Oracle, Informix, and that sort of thing. So in the first interview, I mean, I had learned about transactions as one part of relational database systems. So I had learned about transactions. I know it's a huge field. I had just done one course on transactions, right? So I've learned the basics, but I know it's a lot more complex. There could be so many more things to it. So the person who was interviewing me asked, "Do you know much about transactions?" So knowing what I knew, I was thinking about all the complex systems and thinking he might ask me all those details about transactions. I said, not much. I was very hesitant and said, not much, right? And so that was the end of it. So we just talked about it. That's it. I didn't hear back from them, right? Uh, the other company, the Informix, when the question was more direct. What is a transaction, right? So that was very clear to me. I said, okay, the transaction is something that takes a database from one consistent state to another consistent state. So that impressed him so much. And so that went on and on and on. And anyway, I ended up getting the job. But the point is how communication is important. It starts with listening to what the other person is saying. I could have said the same answer to the first person when he asked, do you know something? It was just a question that was framed differently. If I'd given the exact same answer to that person who asked me first, things might have turned out very differently. So it starts with listening, understanding what the intent of the person you're talking to wants, and then answering it in a way. So that's verbal communication. Similarly for written communication and so forth. Very important communication. Third, do what you love, like, and what creates an impact that helps others. That is very critical as well. A lot of things you would do second nature. You don't think about it. Everything works very good. But there are some points in your life you would go into a crossroad. You would see many options. All of them look good to you. So how do you decide? That's when you use, okay, which one do I love and like more? Which one is where I can create an impact, help others more? You choose that and you're bound to be very successful in that. And the last thing I wanted to mention here is learn who and what to trust, right? So as you're working now, you would be doing a lot of things. So for example, I always go back to writing, I mean, the example of writing a code, right? As a software engineer, what else comes to my mind? So anyway, you write code or you design a circuit or whatever it is. You get a job, you do the same things. But it is always a teamwork, right? You work on one part of it and there are so many others you work with. So you should know what they say is something that you trust that will make the whole thing work. And as you go in your career, say you get one promotion, two promotions, so on and so forth, and you suddenly find yourself leading multiple people. And so for you to be able to scale your abilities, you cannot be going and verifying each line of code that person you're leading, because there could be 5-10 people. You cannot be verifying each line of code or each circuit design they do or anything. At some point, you'll have to put two and two together and know what they say and how to trust, ask the right questions and so forth. Doing that will let you scale a lot more, be impactful to a larger number of people. Important to see who and what to trust. So these are some of the attributes will make you successful. But what is the bedrock? What is the foundation of all of this? Say you're building a house, you and your partner or your friends or your wife, whoever it is, you build a house together. Um, there is no argument about the foundation. That's the foundation, right? It has to be there in a house. Maybe you argue about 2 rooms, 3 rooms, or what color paint do I use, blue or red, or what paint. That you can argue where the window is and stuff like that. But the bedrock, the foundation, there is no argument. Of house needs of. So as a person, as a human being, I think mindfulness, being in the moment and being in the present, gives you that bedrock. What is mindfulness, right? A state of being of a person with the right energy at the right time to do the right thing is mindfulness. Again, it is the state of being of a person with the right energy at the right time to do the right thing. Think about it, right? that is mindfulness. Sometimes doing the right thing means doing nothing. In some situations, that could be the right thing. In some situations, it could be doing something very aggressively. So having the energy and being in the moment to decide to do the right thing at the right time is mindfulness. That is one of the foundations as a human being, right? And how do you achieve that? So here are some of the tips. So body, mind, and spirit is what makes a person whole. And just like you eat nutritious food, you exercise, take rest, and sleep. That's like a workout for your physical body. And like that, any of the course, again, as a students, the coursework that you do, or any hobbies that you might have, the puzzles for people in the profession, working, the work they do, newspapers, books, magazines, all these are like workout for your mind. And mindfulness practices, people talk about meditation, or anything that inspires you, friendships that inspire you, any hobbies that could inspire you, any music, dance, anything that inspires you is all like workout for your soul, right? So there are limits to everything. Each one decides what your limit is and go based on that. So having the right balance of this makes you a whole person. And I think with that gives a peace of mind and harmony within yourself. When you have that, all your loved ones around you will feel that and be peaceful, and that emanates throughout your community, your state, your country, the whole world. Everything becomes harmonious, right? So that's the goal of doing this. So hope it is a little, you find some insightful. There are some reference tips that I've included here below. And the last thing I wanted to do is take a snippet from this. So you probably identify, you've seen this person. This is, for those of you who can't find, I mean, this is Steve Jobs. He's the founder of Apple. So he gave a commencement speech for graduates at Stanford University. I was lucky enough to be able to go and visit, actually be there live for that talk. It's now out on YouTube. Anybody can go and take a look at it. But I just took a small 30-second snippet from that.
I'm convinced that the only thing that kept me going was that I loved what I did. I'm convinced that the only thing that kept me going was that I loved what I did. You've got to find what you love. And that is as true for work as it is for your lovers. Your work is going to fill a large part of your life. And the only way to be truly satisfied is to do what you believe is great work. And the only way to do great work is to love what you do. If you haven't found it yet, keep looking and don't settle. As with all matters of the heart, you'll know when you find it. And like any great relationship, it just gets better and better.
Okay, there you go. So, oops, I think it stopped.
I'm convinced that the only thing that kept me going was that I loved what I did. You've got to find what you love. And that is as true for work as it is for your lovers. Your work is going to fill a large part of your life. And the only way to be truly satisfied is to do what you believe is great work. And the only way to do great work is to love what you do. If you haven't found it yet, keep looking and don't settle. As with all matters of the heart, you'll know when you find it. And like any great relationship, it just gets better and better as the years roll on. So keep looking, don't settle.
Yep, keep looking, don't settle. So basically he says, stay hungry, and you will find a success, peace, and harmony in what you do. So yeah, so that's essentially what I wanted to share today. Again, it is thank you for providing the opportunity, St. Joseph's, Dr. Jnana Kausalya and the entire team there. Thank you for providing the opportunity. It was an honor to be able to spend this time with you. Really appreciate it. So
thank you, sir.
Yeah, we have time for some questions, and I'm also curious if you have any comments about what you do in college, any projects you do. I'm just curious to hear about what you do, or if you have any questions, we can talk about it.
Yes, so we have a few questions from the participant side.
Sure.
Our first question is that, how do you protect sensitive information handled and stored by the third-party vendors?
Right, okay, good question. So how do you store sensitive information with third-party vendors? So nowadays that becomes more and more critical, right? With all the cloud-based technologies, it used to be that all of it was managed within the on-premise, within the customer's their own premises. Now with cloud technologies, what you're saying is pretty much very, very common, especially in newer projects. You could have processing from one vendor, storage in some vendors. So like you said, how do you protect your data in third party? Very, very common, good question. So there are, again, several technologies to enable that. Encryption is one big thing. When you encrypt the data, you as a customer, you need a key to decrypt it. So even though the actual data is being stored in third party, encryption will protect your data from anybody else seeing it. Only anybody with the key is the only person who can see it. So there are technologies like Key Protect, Vault, HashiCorp's Vault. Those are some of the technologies and products that will help you with that encryption and those kinds of technologies that make it secure for your data to reside outside your premise in a third-party vendor sort of. So, so I hope that answers the question. Yeah.
Yes, sir. Thank you, sir. Our next question is, do we have a cyber insurance?
A good question. That's a very good question. Again, insurance is up to the person. So when I say the person, I mean the underwriter, the insurance underwriter, right? The other day I was just listening to something outside of the technology context, and they said, I think it was Warren Buffett's company, right? He's huge into insurance. So as long as you can convince the insurance provider to write an insurance for you, then you can do it. Why not, right? So you say what the problem is, and they understand the risk. Some common things like, so you take your health insurance, auto insurance, those are well-known issues. So you can just go to the store, just like you go and buy bread and your fruits and vegetables, you can buy insurance for, say, car. But when it comes to cyber defenses and cyber security, it's a little bit more complex. It depends on how much data you're trying to protect, what is the value of the data, and so many parameters that are there, how many people are affected. It all comes down to dollars and what is the probability of that data being lost. And so if you are able to talk to the insurance provider about all of this and you come to an agreement, why not, right? That insurance provider can say, hey, okay, that makes sense. We can write an insurance policy for that, and they would do it. So I would think this is more customized. So you would have to go and do, I'm not aware of anything off the shelf like a cyber insurance, a blanket thing. And it makes sense because everybody's situation is quite unique. And so this has to be customized, a cyber insurance. So that's what I think.
And we have one more question. What % of our data is encrypted when stored?
What % of the data is encrypted when stored?
Yes.
Right, yeah. So nowadays there are several ways you can think about encryption, right? So there is, when data is being computed in memory, data is in transit. So that is one place where data resides. And the other is, once processing happens, it has to be stored. So it goes to your hard disk and so forth. So and in the network, when it's flowing between microservices, that's one thing. So these are 2 or 3 places where there's potential to snoop into data. So you can encrypt all of this. Again, when you say what % of the data, it comes down to your own policy. Now there are technologies to encrypt everything. Even in-memory processing can be encrypted. A hard disk can be encrypted. In transit, on the internet. So you have SSL and the TLS, all those protocols will help you encrypt in transit. So again, as a customer, you'll have to decide. So I guess the recommendation is you encrypt everything. Again, there is always a price to be paid, right? So when you encrypt data, there is some performance that you have to give to unencrypt the data and process it and so forth. So people are working on optimizing all of those. So you do the cost benefit analysis, and see where all you would need and where you can mitigate risk or where there is not much risk. Say, for example, you have a very secure processing environment. So maybe you don't need encryption when the data is being processed. Maybe you need only encryption when the data is stored. So for example, you don't want somebody just takes your hard drive and goes away, then encryption becomes useful, right? So if it's encrypted, then even though somebody has stolen your hard drive, they cannot take or access the data. So encryption becomes useful there. So you decide whether, in this case, you consider 50-50%, right? If you want to only encrypt data at the disk level and not in the processing, consider that as a 50-50. So that, or if you want 100% encrypt everything, then you can do that. So basically what I'm trying to say is there are technologies to encrypt every aspect of computing. And you as a customer or as a designer of the software product chooses how and how much you want to encrypt. 100%, 10%, 20%, whatever. So.
Yes, sir. We have a last question. Is online banking safe? Does it has security threats or breaches?
Yeah. Online banking. So things have evolved. So if you think about it, at least in the US, I know online banking has been there for at least 20 or 25 years, right? Maybe the websites and stuff like that came later. Before, when we talk about online, even phone banking, right? So you can just take a phone, press keys to affect bank transactions. So that's a form of online banking. So it's been there for quite a while. Over the years, they have enhanced security systems with the latest encryption technologies and two-factor authentication. So yeah, there is so much more to security. I didn't have a chance to talk about all of this. So two-factor authentication is there. A lot of those, like denial of service attacks. Anyway, so coming back to banking, all the banks work on, they try to be, it's very, very, very critical for them. So some of the customers you work with banks, any change that you have to do on their systems goes through multiple layers of approvals. So basically they make sure that any change is so secure, they test it so much and try to make it as secure as possible. So they try to have the latest technologies to prevent any of the breaches from happening. So security is evolving over the period of years. It's gotten stronger and stronger, but it's always a cat and mouse game, right? So there is always some hacker who could be smarter and find something to break it. So and banks keep up with it. So all I can say is over the period of years, the security has gotten better and improved to an extent that a lot of people trust it. And like I mentioned, for the credit card case, even in banks, they try to minimize the liability for you as a user. So when you try to do some transaction and you find something has lost that is not in your control, it's because of an online security breach or something else, then the banks try to take the liability out of you, meaning if you report it within a certain reasonable amount of time, then you are not liable for the loss. Again, various countries and various banks will have different policies, but what I just said is a very, very common policy, at least in the US. I'm sure in India too, the big banks have such policies, but you'll have to check with the bank's policies. And it is in their best interest to provide such securities because it provides a lot of efficiencies for them to in their business ROI and stuff like that, return on investment, that they would enhance the security of their systems.
Thank you, sir. Thank you, sir. That's the end of question answer session. And the session was really informative and fruitful. Now, I invite Dr. Rohin Imam, Professor and Head of Staff and Lab Affairs, to express her gratitude.
Thank you so much. Good morning, Mr. Sumant, sir. Again. Good morning, all. Myself, Dr. Rohini, Professor, on behalf of Department of ECE, St. Joseph Institute of Technology, St. Joseph Group of Institutions, I thank Mr. Sumant Rajagopal, Software Engineer, IBM Corporation, California, USA, for his informative speech on cloud security, common vulnerabilities, and ways to address them. Thank you so much, sir, spending your time and giving information on common security issues, cloud service system architecture, OWASP top 10 vulnerabilities with examples, and above all, for sharing your experience and giving some tips to the current generation. I would like to thank our management for giving us the opportunity to organize this webinar. I thank our head of the department, Dr. C. Gnanakosilana, and organizing team for arranging this webinar. Finally, I thank all the faculties, research scholars, and students for their active participation. Thank you all. Thank you, sir.
Thank you.
Again.
Thank you very much. It was an honor to present to you. I had a good time. Hope you all enjoyed it as well. Thank you again. It was great. Thank you so much.
Thank you,
sir.
Mr. Sumant. Thank you, Mr. Sumant, for the wonderful session and spending